Okay, sorry we got cut off before. I'm going to finish up where I started in part 1, and this is part 2 of section 1.3. And when I left off, I had shown you how to add matrices, how to subtract matrices, and I was working on scalar multiplication. And on scalar multiplication, really all it is, you got a number on the outside. It's like the distributive property. You're going to take the number on the outside times each one of the 4 entries on the inside. So I had 4 times 2, which is 8. Kind of hard to see, but that's an 8. I had 4 times 3, which is 12. 4 times 0 is 0. And 4 times 4 was 16. So as far as the operations, I think it's pretty straightforward, pretty easy to follow. I don't think you'll have any problems with that. Okay, so let's move on. Give me a second here. Okay, let's go to matrix multiplication. Matrix multiplication is going to be a little bit tougher. So here's what we're going to do for multiplication. You're going to multiply the rows of the first matrix times the columns of the second matrix. So in my example, you can see I have 2 matrices. Here's the first one, there's the second one. Before we get started, you need to look at this. Look at the dimensions of the first. And the first matrix, that's a 2 by 2. This is important. The dimension of the second matrix, 2 by 2. So it's going to be an easy one. Before you can multiply matrices, you have to look at these 2 numbers right here. The second one here and the first one there. Those have to be the same. If you look and they're not the same, then you cannot multiply them. So you cannot multiply any 2 matrices. You have to have those 2 numbers match before you can. Now, the outside 2 numbers, they give you the dimensions of the answer. This will make more sense in a little bit. So my answer is going to be a 2 by 2. Okay, now let's see how the process works. I do this, especially early. You're taking the rows of the first. So I'm going to circle the rows of the first. That's what it says here, rows of the first. I've got 2 rows. Times the columns of the second. So I'm going to circle the columns here. To come up with my answer. Now I'm going to write all this stuff out. As you go on, you won't do all of this. This is row 1. That's row 2. This is column 1, column 2. In your answer, you're going to have row 1, which will be these numbers, and row 2, which will be these numbers. You're going to have column 1, and you're going to have column 2. Okay, again, I'm going to do something. You won't have to do all of this, but we said the answer is going to be 2 by 2. So that means I'm just going to put something out here. These are just space holders. Where I'm putting these, you're going to have a number in each one of those in your answer. So we have to figure out what number goes here. So this number is in row 1, column 1. So over here, I'm going to take row 1 times column 1. Row 1 has a 1. Column 1 has a 5. Plus, I got a 2 in row 1 and a 7 in row 2. So when you take 1 times 5, that's 5, and 2 times 7 is 14. 5 plus 14, my answer is going to be 19 down here. So I'm showing you the work up on this one. So that was row 1, column 1. I took row 1 here, the 1 and the 2, times the 5 and the 7. You take the corresponding numbers. 1 was the first one here, 5 is the first one there. So 1 times 5. 2 was the second number, 7 was the second number. So 2 times 7. So then you got 5 plus 14 gives you 19. So let's go to the second one, the second entry. That's going to be row 1, column 2. Row 1, column 2. So I'm going to take row 1 over here times column 2. So the first number here is a 1, the first number there is a 6. So 1 times 6 plus, I'm going to run out of room, 2 times 8. 1 times 6 is 6. 2 times 8 is 16. 6 plus 16 is 22. Go down here. This is row 2. So row 2, column 1. So I'm taking 3 times 5 plus 4 times 7. 3 times 5 is 15. 4 times 7 is 28. 15 plus 28 is 43. And then the last entry, I'm going to take row 2. This is row 2, column 2. So over here I'm going to take row 2 times column 2. So I got 3 times 6 plus 4 times 8. Should have had my bracket way out in here instead of there. 3 times 6 is 18. 4 times 8 is 32. 18 and 32 is 50. So going back, we started out with 2 matrices. When you multiply, you have to go through this whole process to come up with these numbers. This is different than what you did with addition and subtraction. If that's all you saw and I told you to multiply, you probably would have just taken 1 times 5 and put a 5 here. And then 2 times 6 is 12. That doesn't work. And there's reasons, but for right now, that's where we're at. Let's go to the second example. We want to multiply. So again, I got a 2 by 2 and a 2 by 2. So when I multiply, I'm going to end up with a 2 by 2. Okay, so I'm going to take the rows here. Oh good, this has got zeros. You're going to develop an appreciation for zeros if you didn't have them before. When you multiply by 0, things happen. Things drop out. Okay, so the first column on the left, or first row on the left and the first column on the right, I see 1 times 6 and 0 times 0. So 1 times 6 plus 0 times 0. 1 times 6 is 6. 0 times 0 is 0. 6 plus 0, put a 6 down here. Okay, first row, second column. I see 1 times 2 plus 0 times negative 1. Oop. So that's going to be 1 times 2 is 2. That's 0. 2 plus 0 is 2. Go to the second row. So second row, first column. I see negative 2 times 6 plus 3 times 0. Negative 2 times 6, 3 times 0. That's negative 12 plus 0 is negative 12. And second row, second column. So I see negative 2 times 2 plus 3 times negative 1. Negative 2 times 2 is negative 4. Negative 4 plus, that's negative 3. This number is going to be negative 7. And that's the answer. So when you take a 2 by 2 times a 2 by 2, you get a 2 by 2. Remember, these two numbers have to be the same, and the outside two numbers give you the answer. I'm staying with 2 by 2s. That makes everything somewhat simple for you. Okay, here's my third example. I'm staying with the 2 by 2s. 2 by 2, 2 by 2. Insides are the same. The outside, that gives you the answer. So I'm going to end up with a 2 by 2. Now the answer is going to be 2 by 2. Okay, we're going to circle the rows. I don't know if you noticed, but these are really the same two problems, except I switched the order of the matrices. This matrix came second, that one came first. See what happens. Okay, I got 6 times 1 and 2 times negative 2. Try to stay organized on these because you'll get mixed up real quick. That's 6. That's negative 4. 6 plus negative 4 is 2. Then we're going to have 6 times 0 plus 2 times 3. 0 plus 6 is 6. Second row, first column. Second row, first column. I got 0 times 1 plus negative 1 times negative 2. So I got 0 plus 2 is 2. And the last entry, that's second row, second column. So I'm going to take the second row here times the second column there. So 0 times 0 plus negative 1 times 3. So that's going to be 0 plus negative 3 is negative 3. Here's what I want you to notice. I had the same two matrices. All I did was change the order. I got different answers. When we multiply regular numbers, let's say I took 3 times 5, that's 15. I don't know why I said 5. 3 times 5 is 15. If I turn around and took 5 times 3, that's going to be 15 also. So we know from your basic algebra that it doesn't matter what order you multiply them, you get the same answer. That's called the commutative property. You don't need to know that, but it's called the commutative property. So what we're saying up here, we switched the order, we got different answers, so the commutative property doesn't work for matrices. I don't know if you remember your basic properties, but you know, we had the distributive property, there was commutative property, there was the associative property, and we use those quite a bit. Associative, you change the group. Okay, let's step it up a little bit. We've been doing 2 by 2s. Now I'm going to do a 2 by 2 matrix and a 2 by 3 matrix. We can do this because the inside numbers are the same. The outside tells me that we're going to have a 2 by 3 answer. Okay, now circle the rows. Circle the columns. And just always think of them as row 1, row 2, column 1, column 2, column 3. That helps you keep organized. So when we go over here, we're basically going to have 6 spots we got to fill. So this spot is in row 1, column 1. So that tells me I'm going to take row 1 here, 8, 3, 1, and 3. I'm going to do this. 8 times 1 is 8. And 3 times 3 is 9. See what I did there? 8 times 1 is 8. 3 times 3 is 9. So when I get down here, I can just put 17. I'm going to go to this one. I usually go across and then down to the next row. Okay, so this is row 1, column 2. So I see 8 times 2 is 16, plus 3 times 0 is 0. That gives me a 16 right there. First row, third column. First row over here, third column. I see 8 times 6. 8 times 6 is 48. Plus 3 times 1. Down here I'm going to put a 51. Now we're going to the second row. So we're going to look at the second row over here. So I got 6, 1 times 1, 3. First row, first column. I got 6 times 1 is 6. Plus 1 times 3 is 3. 6 plus 3 is 9. Second row, second column. Second row, second column. 6 times 2 is 12. Plus 1 times 0 is 0. 12 plus 0 is 0. And our last entry, that second row, third column. Second row, third column. 6 times 6 is 36. Plus 1 times 1 is 1. 36 plus 1 is 37. And that's your answer. Okay. Let's look at the next one. Can we even do something like this? Well, it goes back to your dimensions. What are the dimensions of the first one here? Basically, it's just a single column, isn't it? That would be a 3 by 1 matrix. This one over here is a 1 by 3. So the inside's the same. My answer is going to be 3 by 3. It's going to get bigger. I can go straight to the answer on this one. When I circle my rows, I got row 1, row 2, row 3. Over here I got column 1, column 2, column 3. Write that in over here. So when we go, the answer is 3 by 3. So I'm going to have 1, 2, 3. I got a first row. I got a second row. I got a third row. I'm just putting dots there representing the places where the numbers are going to go. When I want to find this one, that's row 1, column 1. So row 1 times column 1 is just 1 times 4. There's nothing to add. That number is going to be a 4. Row 1, column 2, so 1 times 3 is 3. Row 1, column 3, 1 times 1 is 1. So there's no addition because there's only the one set of numbers. We go to row 2. 2 times 4 is 8. 2 times 3 is 6. 2 times 1 is 2. So really all you do is take 2 times each of those numbers. And on the bottom row, all I'm going to do is take 6 times each of those numbers. So 6 times 4 is 24. 6 times 3 is 12. And 6 times 1 is 6. When you get done, you have a 3 by 3 matrix. Okay, example 6. Example 6 looks just like the other one, except I switched the order. We know we're going to get a different answer. The dimensions on this one are 1 by 3. The dimensions over here, 3 by 1. So the inside's the same, so that tells us we can do it. And the answer is going to be a 1 by 1. So that's simply just going to be one number. We've got one row. We've got one column. We're going to take 4 times 1 is 4, plus 3 times 2 is 6, plus 1 times 6 is 6, that's the answer. Oops, I'm sorry. Go back over. I took 4 times 1 to get 4, 3 times 2 to get 6, and 1 times 6 to get 6. When you add those, you end up with 16. Okay, let's do one more and then we're gonna break again. Okay, so now I got a 3 by 3 times a 3 by 3. I'm not going to put the dimensions because we can see it's going to be the same. Your answer is going to be a 3 by 3. So I'm going to circle my rows. Circle my columns. I'm going to have a 3 by 3 answer. We could do this just by looking at it. I'm going to take 4 times 1 is 4, 3 times 0 is 0, 2 times 0 is 0. So that's 4 plus 0 plus 0. My first number is a 4. I'm kind of jumping a little quicker here because I got so many zeros. We do a lot of this in our head. First row, second column is 4 times 0, which is 0, 3 times 1, which is 3, and 2 times 0, which is 0. So I got 0, 3, and 0. That adds up to 3. And then first row, third column, 4 times 0 is 0, 3 times 0 is 0, and 2 times 1 is 2. So it's 0 plus 0 plus 2 is 2. Let's go to the second row. 7 times 1 is 7. 6 times 0 is 0. 1 times 0 is 0. So I got 7 plus 0 is 7. Second row, second column. I got 7 times 0 is 0. 6 times 1 is 6. And 1 times 0 is 0. So I had 0, 6, and 0 is 6. Second row, third column. 7 times 0 is 0. 6 times 0 is 0, and 1 times 1 is 1. So I got 0 plus 1 is 1. Third row. Third row, first column. 0 times 1 is 0. 2 times 0 is 0. 5 times 0 is 0. So I got 0 plus 0 is 0. First row, second column, I'm going to have 0 times 0 is 0. 2 times 1 is 2. And 5 times 0 is 0. So we got 0 plus 2 plus 0 is 2. Third row, third column, I got 0 times 0 is 0. 2 times 0 is 0. 5 times 1 is 5. So 0 plus 5 is 5. Now here's what I want you to notice. We started out with this matrix over here. 4, 3, 2. 4, 3, 2. 7, 6, 1. 7, 6, 1. 0, 2, 5. 0, 2, 5. What happened, I multiplied this matrix times this one, and I got the same thing. This is called the multiplicative identity. You can just call it the identity. This pops up a lot. That's a 3 by 3 identity. There's a 2 by 2, 3 by 3, 4 by 4, and so on. But that happens quite a bit. Now, compare that to regular numbers. If I had the number 5 and I multiply by 1, you get 5. If I had 7, you multiply by 1, you get 7. So 1, the number 1 is the multiplicative identity for regular multiplication. Anything times 1 is going to give you the same thing you started with. Well, that's what this is for matrices. If I ever ask you what the multiplicative identity would be, remember that the 1s are on the diagonal and you got zeros everywhere else. That should look familiar because we kind of use that with Gaussian. That was kind of our goal. Okay, I think I'm going to go ahead and try to squeeze this in on this tape. This is an easy concept. This is more of a shorthand type thing. Many times you'll have matrices and they'll identify them with a letter. So we're going to let matrix A be this matrix here, 1, 2, 3, and 8. And matrix B is this one here, 5, negative 1, 2, and 0. And if you can imagine, you could input this into, say, a calculator or computer. You identify what the matrix are, and then you can set up your operations using letters. So if I want to take A plus B, that's the same thing as doing this. 1, 2, 3, 8, plus 5, negative 1, 2, and 0. So the answer is going to be 1 plus 5 is 6. 2 plus negative 1 is 1. 3 plus 2 is 5. And 8 plus 0 is 8. So many times on a test, I won't give you a problem that looks like this. I'll define the variables up top, and I'll write it down like that. And you'll notice once you have those, I can come up with all kinds of possibilities. So now, let's say we go to this one here. 2A minus B. That means I'm going to take 2 times this matrix. I'm just going to do that real quick. So 2 times 1 is 2. 2 times 2 is 4. 2 times 3 is 6. And 2 times 8 is 16. This says subtract whatever B is. And B was up here at 5, negative 1, 2, and 0. So 2 minus 5 is negative 3. 4 minus negative 1, that means 4 plus 1, so that's 5. 6 minus 2 is 4. And 16 minus 0 is 16. Okay, the next one says 3A plus 2B. So I'm going to multiply 3 times each number up here. 3 times 1 is 3. 3 times 2 is 6. 3 times 3 is 9. And 3 times 8 is 24. Plus 2 times B. So if I go here, here's B. So 2 times 5 is 10. 2 times negative 1 is negative 2. 2 times 2 is 4. 2 times 0 is 0. Three plus 10 is 13. 6 plus negative 2 is 4. 9 plus 4 is 13. And 24 plus 0 is 24. Okay, and then the last one I have, it says A times B. Okay, well, there's no easy way of doing that. That just means you're going to have to go 1, 2, 3, 8. Times 5, negative 1, 2, and 0. So we're multiplying, so we're going to circle the rows, circle the columns. First row, first column. 1 times 5 is 5. 2 plus 2 is 4. Eventually I'm going to put a 9 down there. One times -1 is -1. 2 times 0 is 0. -1 plus 0 is -1. Second row, first column. 3 times 5 is 15. 8 times 2 is 16. 15 plus 16 is 31. Second row, second column. I'm going to have 3 times -1 is -3. Plus 8 times 0 is 0. -3 plus 0 is -3. So when I write them like this, what makes it easy is to write the problem down, but you still got to do the same work. Okay, I hope you find this section to be fairly easy for you compared to, say, Gaussian. Gaussian was a little involved. You got to know the rules to do all of that. But when you're add, subtract, or scalar multiplication, that's pretty easy. Multiplication, once you get the hang of it, it's not bad either. All right, that wraps that up for now. Thank you.